Hey guys, Rich here, Finn's Garage. How you doing? Today, I'm not doing any install videos, no tutorials. Since it's Tuesday, let's call this Tech Tip Tuesday. I want to talk a little technical on a certain aspect of adjusting your lifters inside your cam chest. A lot of people do cam jobs, a lot of people install lifters, they do the push rods, and I really want to talk about the technical aspect of what goes on when you adjust those push rods and how you set your lifters when you do that cam job. So for those of you that don't care about the technical aspect, you just want to put it in there, take people's advice, do your 3.5 turns, 2 turns, call it a day, this video is not for you. But if you want to really technically understand what goes on inside your engine, you want to know how that lifter works, why we adjust it the way we do, this video is for you. All right, so I'm going to give you some technical insight. I did create a drawing. I'm going to admit right now, I'm not the artist. I am a mechanic. I'm not an artist. But I'll walk you through the pictorial of what I did. I drew up an anatomy of a lifter. I'll talk you through what we adjust and how that plays, and also how to calculate how to adjust it based on the style push rods you have. You know, different push rods have different, what they call TPI. That stands for threads per inch. That's basically how much distance you're getting every time you make a full rotation or a flat rotation on the push rod. So let me zoom you in on the drawing. I'll talk you through it. We're going to talk some technical aspect here, and hopefully you guys learn a thing or two. So let me get the drawing up. I'll zoom in so you can see it, and I'll talk you through it. Okay guys, I have you zoomed in. Hopefully you can see this. There's a lot of busy stuff on this chart, but I really want you to pay attention just to the lifter diagram right now. Again, I'm not an artist, but I think you'll get the gist and kind of explain what's going on, right? So when you look at your lifter, this is basically a very high-level sketch of what's inside that lifter, right? We know at the top of the lifter, that's where our push rod sits into that cup. And then below that cup, you have an oil metering hole where the oil goes in and out of the lifter that feeds up through the push rod, that feeds up into the rocker arms. And then inside you have your plunger. This plunger actually moves up and down, okay? Below the plunger, you have a check valve, you have some springs, one for the plunger as well, and that's kind of what keeps that pressure on there in conjunction with the oil flow that flows in and out of the hydraulic filter. So we all know we have our oil holes on the side of the filter, so that's how the oil primarily gets into the filter. It goes in, it bleeds up the filter, it keeps constant pressure inside this hydraulic assembly, feeds oil throughout the rest of the top of the engine. So the main thing about this, when you are adjusting your push rods, when you are adjusting your adjustable push rods, it's very critical to understand what's going on as you make that adjustment, right? There is, if you look at these 2 arrows inside, this is what, you know, basically if you went to mechanic school and stuff like that, they would refer to this as expansion, engine expansion. And that, you know, as we know, as things get hot, things get cold, they expand. So the purpose of that travel is to keep constant pressure on that push rod that is controlling your valves up and down, right? You know, you don't want to lose that pressure. You want to have constant, you want to have a constant connection between your cam, that this lifter sits on the cam lobe. This lifter then controls the push rod that basically goes into your rocker arms, and the rocker arms open and close your valve. So you want to maintain at every revolution, as that engine's running, constant pressure. You know, sometimes you'll see a lot of videos where there's a lot of valve train noise and stuff like that. So it could be you're not adjusted correctly, or you got some slap in there and things are making noise. So that's what this travel or this engine expansion slot is. Now this is where it gets very critical, and this is why those turns based on your push rod adjustment is very critical. This distance in most standard lifters, from the bottom of the plunger to the bottom of the channel inside the lifter, that's in all standard lifters, most of the lifters out there, all your standard S&S lifters, all your standard lifters are all at 0.200 of an inch. So that's 200 thousandths of an inch. So this travel inside that lifter, the only tolerance you have is 200 thousandths of an inch. And that's less than a quarter of an inch. So you have to understand that that's the amount of play that you have when you preload these lifters and you set those push rods and you make those adjustments. The target distance that you want to set these push rods is approximately 50%. So right in the middle of that 200,000, which equates to the 100 thousandths mark, right? So your ideal application, your ideal measurement is getting this lifter set with that push rod where it's 1/1000th of an inch. And that's why it's very critical when you set that push rod and you make those adjustments that you wait until the lifter bleeds down. And basically what that's doing is you have spring pressure from your valve that's basically putting that pressure down on this push rod. And you know, if you set this push rod correctly, the most it will go down is 100 thousandths of an inch. Well, you'll be a dead center of that travel. So you have to wait for this to bleed down and the oil to kind of, dissipate and bleed out. So once that bleeds out, we all know, or most of us should know, that you then will be able to actually twist the push rod and actually turn the push rod. At that point, you know your valve is fully seated. There's no more pressure being applied to this plunger, and your plunger is now sitting at approximately 100 thousandths of an inch. Now it's time where you can turn over the engine and do your other adjustment on the other lifters on the other cylinder. So that's really key to understand is you only have 200 thousandths of an inch play, and your target travel to adjust that plunger in that lifter is 100 thousandths of an inch. So this is key to calculating and know how to get to 100 thousandths of an inch, right? So if we go up here to this section, right, I put two different, scenarios. Screaming Eagle push rods. The push rods that I prefer is the ones that I always will try to use in any of my engine builds. I like them. They're a little bit more sturdier. They're a thicker build. Overall quality of those push rods are just really strong. Never had one fail. Never had one come loose. Never had one, create any issues in any of my builds. So I always try to use, Screaming Eagle push rods. Those push rods are 24 threads per inch. What that means is in 1 inch of travel on that push rod, you have 24 threads. So if you do a Google search, if you use ChatGPT, if you go out there and you look for information and ask, and I'm asking you to go do this, pull up your phone right now and do a search on Screaming Eagle push rods, 90% of the time it's going to come back and tell you it's 32 threads per inch. That is completely inaccurate. These Screaming Eagle push rods are 24 threads per inch. You will get your instruction sheet that's inside there, and it will tell you how to adjust it, which confirms they are 24 threads per inch. So trust me on this one, they're 24 threads per inch. Now, to way to calculate, to maintain or get to that 100 thousandths of an inch, very simple calculation. You just do your 100 thousandths, multiply it by the TPI, which is the 24, and you get 2.4 turns. So we know on push rods, on most push rods, there's 6 flats in 1 full rotation. But 2.5 turns is perfectly fine in this application. And the instruction sheet for Screaming Eagle push rods will tell you 2.5 turns. And that's why, okay? On a majority of all your other aftermarket push rods, your S&S push rods, your Fuel Moto push rods, almost every other aftermarket push rod out in the market is 32 TPI. So that's 32 threads per inch. So again, very simple math. 100 thousandths, again, my target of how to set this preload on this lifter is 0.100, just 100 thousandths times 32 TPI gives you 3.2 turns. We know S&S, if you look in the forums, they say 3.5, 4 turns. If your valve train's noisy, sometimes 4.5 turns. So you got to be careful that every time you're doing that, you are now putting that plunger in a more tight situation, right? And when this plunger is put in those situations, you're putting more stress on that lifter. You're putting the lifter in a scenario where if your engine expands based on heat, it may not be able to keep constant pressure on that push rod. That is the ultimate goal of this lifter, is to keep constant pressure on that push rod and make that valve operate the way it should. So if you're going over those 3.5 turns, be very mindful of that and be very, very, cognizant of that, right? We see tons of lifters out there on the forums, on Facebook, failures. And are you over adjusting them? Possibly. Are you compensating for a noise that's causing something else to create a noise? Possibly. But mathematically, at a 32 TPI, to maintain that distance, it's 3.2 turns. 3.5 turns is perfectly fine, okay? Now, to calculate this, so if you don't have a push rod that's 24 or 32, or it seems to be like a 28, or there's some push rods out there that are 36 TPI, some of the older ones. There are some 28s as well. All you do is just do 1 divided by the TPI, so it's 1 full turn divided by the threads per inch will give you how much distance you're moving in 1 full turn based on that TPI. In this case, I use 24 for an example. So 1 full turn equals 41.6 thousandths of an inch, right? And again, here's where you come to the calculations. You get 100 thousandths divided by 1 full turn equals 2.4, okay? So that's the technical breakdown. If you have any questions, comments, or you need help on doing calculations, shoot me a comment, shoot me a note. I'm glad to help you out here. But those of you that are working on these engines and you're doing cam work and you're putting adjustable push rods in there, at least have the know-how of wanting to know what you're actually doing mechanically inside those engines, right? Know what you're doing when you're making those adjustments. If something's not seated right, know why and know what you're doing inside the engine, right? Take pride in the work you're doing. Take pride in the knowledge and the expertise and the technical aspect of what you're doing. So one other thing I want to mention here is I'm going to give a shout out to Cyclerama down here in the Tampa Bay area, in the Pinellas Park area. I try to use their CR202 lifter. It's a great lifter. I have it in my personal bike paired up with the Screaming Eagle push rods, running on the Cyclerama 483 cam. These lifters are what they call limited travel lifters, right? So you don't have that same gap or that same expansion, engine expansion, or that lift to travel inside of those lifters. These lifters are probably the quietest lifter that I've ever used. It's paired up in my Fat Boy with my 483 cam, and that valve train is so quiet. The thing about this though is you don't have the 200 thousandths travel. These are actually approximately 130 thousandths travel. So when you are using a limited travel lifter, and make sure you know what type of lifter you're putting in your build, make sure you know the specs, because you will not adjust it correctly and you'll have engine noise. You could bend your valves, bend the push rods, and create catastrophic failure in your engine. So this specific lifter is 130 thousandths. And again, I want to get in that midpoint of that travel range. So their preload on this lifter is 0.065, so 65 thousandths of an inch. Now, knowing that I use the Screaming Eagle push rods, times that by 24, my preload, when I install these lifters in my bike using that lifter, 1.5 turns. 1.5 turns sets that plunger dead center of that lifter to maintain optimal pressure. So if you have this lifter and you don't know what's really going on inside, and you adjust it 3.5 turns, 2.5 turns, you're actually going to bottom out that plunger and you're going to have major engine damage. So anyway, wanted to bring that to you. Very simple math. Take a screenshot of this if you want. Shoot me a comment. I can give you some help or do some calculations for you, but at least know what's going on inside your engine. And again, another tip, when you're setting these, before you do any adjustments, make sure that lifter is filled with oil. There's different ways you can do it. You could pressurize them to bleed all the air out, or you can use an oil can, which works really good as well, is feed the oil through here, and your oil will come in, and then it will start coming out of the top of the plunger. You know you have oil in there. Make sure this lifter is fully primed before you do any adjustment. And when you set that push rod, what you want to do is get it in the rocker cover, and then get it down, you know, sitting in the rocker arm, and then get it down sitting in here where it makes contact. You don't want any up and down play at all. You want it to be what we call zero lash, where it's sitting flush inside this cup. You will not be able to put it up and down. Make sure you're at that point, and then start making your adjustments based on your TPI of your push rod, and really dial in to get in that 50%, whether or not you have a standard lifter or you have a limited travel lifter. All right, guys, so that's it for today. Again, wanted to bring you some technical tips, technical aspect, and give you some insight of what's really going on inside those lifters and how that lifter plays a big part in your push rod TPI and how you set them accordingly to maintain optimal engine operation, minimize noise, and get the best performance out of your bike. So hopefully you guys learned something. Shoot me a comment if you have any questions, need help calculating, you know, what your ideal turns are. Shoot me a note, I'll get back to you. We're looking forward to help you out. And if you like the content, like, subscribe, and talk to you soon. See ya.